Welcome to my kcse revision channel, Marita James. Follow my YouTube channel. Kindly subscribe. Click the notification bell. You get notified once I upload a new video. Today we are looking at chemistry for work, and our topic of discussion is air and combustion. And here I have a summary of the oxygen preparation, the physical properties of the gas, and of course we have the uses and some of the reagents you require for the preparation of this oxygen gas. So oxygen, first of all, you need to have the reagents and the conditions. What are the reagents and the conditions required? One, we have a hydrogen peroxide and a manganese 4 oxide as a catalyst. So one of the reagents required, you can have hydrogen peroxide and then you can use the manganese 4 oxide as a catalyst. Two, we have the sodium peroxide, which is a solid of course, and then now this one is reacted with water. We have potassium chlorate 5. In this case, now the condition is required here is heat is required. Heat is required. This one can decompose to potassium chloride, and of course you will collect the oxygen gas. Another reagents and the condition, we have sodium nitrate. The condition required is heat. Then we have the potassium manganate 7, and then the condition required is heat. These are the 5 methods used for the preparation of oxygen gas. So this one is very important to note. Once the gas has been prepared, it must be dried. So we either collect a wet gas or we need a dry gas. So what are the drying agents? Normally we have the 3 common drying agents that can dry gases. One, you can have a concentrated sulfuric acid. It can be used as a drying agent. And in my earlier discussion, I said that this one must be used when it's drying this oxygen gas, it must be placed in a conical flask. Then we have a fused calcium chloride. This one must be anhydrous calcium chloride, so it is also used as a drying agent. And then finally we have the calcium oxide. Very important to note. So all these are the drying agents. Not only that they are drying the oxygen gas, but there are some other gases which can be dried by these reagents. Now, what is the methods of the gas collection? So once the gas has been dried, you either collect it by use of a syringe when it has been dried. If it is wet, it is collected over water. So methods of collection of oxygen gas, there are only one, and it depends either if you need a dry oxygen gas, then it is collected over water because the gas is slightly soluble in water. When the gas is required dry, it must be collected by a use of the syringe. So the gas could neither be collected by the upward or the downward delivery once it's being dry. Remember, if you followed my earlier channel, my earlier discussion, I said that the only gas which can be collected by a syringe when it is needed dry is nitrogen gas and oxygen gas. Now, how do you test for the gas? It's also very important. In this case here, you will be required also to describe an experiment. If you are required to describe an experiment, then you need the apparatus and the materials you are supposed to use. In this case here, you need a glowing splint, you need the gas chair full of the gas, and of course, you give a very small procedure on how the gas is being tested. So how do you test the gas? Of course, we have the oxygen. So you lower a glowing splint into a gas chair full of the oxygen, full of the gas. What will happen now? In this case, you need to study the observation. So the observation you make, when the gas is lowered into the gas chair full of this one, it relights that glowing splint. The reason is because this oxygen gas is one of the gases, it is the only gas that supports combustion. So the glowing splint relights, indicating that the gas in the gas chair is oxygen. Then we have the uses of this oxygen. So in an examination, you will be asked to give 3 uses of oxygen or 2 uses of oxygen. So in this case, where is oxygen being required? Where is it being used? So it is used as a respiratory aid for patients with breathing difficulties. So in this case, it is used in hospitals with those patients who have a problem in breathing. We can also have, it is also used by the deep sea divers and the mountain climbers. So it is used by the deep sea divers and the mountain climbers. It is used in welding when the gas is mixed with acetylene gas. It is used in welding to produce that very hot flame. The gas is also used in industries whereby it can be used in steel making to remove the iron impurity. So there is this one here in steel making. So you can say to remove this one here, it is to remove the iron impurities. So that is a summary on how the reactions for the preparation of the gas, how the gas is being dried, the methods of the collection of the gas, and then we have the test for the oxygen gas. Then of course we have the uses. When you look at my diagram here, it can also give a summary of what we have already discussed here. So in this diagram, we have a liquid here, and then we have a solid. So when you look at these 5 methods, so we have a liquid of we have a solid of manganese oxide. We have another solid of when the solid is manganese oxide, the liquid must be hydrogen peroxide. And remember I said that the manganese oxide is used as a catalyst. When the solid is a hydrogen peroxide, then the liquid is water. So in this case here, of course, this diagram we must have a tap. So there is a tap here which is controlling the flow of that liquid. So we have a tap. So we must have a tap there. So we have a liquid, then we have the solid, then we have the gas is collected over water. In this case now, the gas collected over water, it is because the gas is wet and it is slightly soluble in water. So when you look at this diagram, we have the solid and then the liquid. So for example, now you will be asking now, name the solid, and name liquid. So for example, this one we can have, for example, we have this as liquid M and call this one here solid K. Give a pair of reagents that are used to prepare oxygen gas. So when you require to name the liquid and the solid, it's very, very important to note. When the solid is manganese oxide, then the liquid must be hydrogen peroxide. When the solid is a sodium peroxide, so we can have this solid K to be sodium peroxide, then the liquid must be water. A pair of reagent must be correct for one to score. So you cannot write that manganese oxide and then you indicate the liquid here as water. You cannot score because a pair of the reagent is not correct. So a pair of reagent must be correct for one to score. So you mention manganese oxide, correct? Then the liquid must be hydrogen peroxide. The solid is sodium peroxide, and then the liquid must be water. Very, very important to note. Now, what are the physical properties of this oxygen gas? You can see on this diagram that this oxygen gas is collected over water. One of the physical properties, because it's collected over water, the gas is slightly soluble in water. And that is why now, those are the properties that makes that oxygen gas to be collected over water. Now, the gas is colorless and tasteless. Very simple. Then it has a boiling point of negative 183. There are some important things that you need to note. In the first few seconds, you are not collecting the gas. Why? So it is important not to collect any gas in the first few seconds of the experiment. So in the first few seconds of the experiment, we might have some gases that has been contaminated. We must have some kind of impurities in the flask. Therefore, they must be removed before the collection of the gas. So it is important not to collect any gas in the first few seconds of the experiment because the first sample is impure and mainly in the air which is in the flask before any gas was produced. So it is good now in order to collect the gas in the few seconds of the experiment to allow the impurities to escape. Now, what are some of the experimental methods that can be used to determine the percentage of the active part of air? Remember, oxygen has various, it can be used in various parts. It can be used during rusting. It can be used during rusting. So, which the active part of air that can react with the iron metal, and then it goes as rusting. Now, how can you find the percentage? What are some of the experiments a candidate or a student is using to find the percentage of the active part of air? So one, you can use of a burning candle. You also use a burning copper metal in air. You can use rusting of the iron filings. Rusting of the iron filings, this one, it can use oxygen, and also you can use using the smoldering phosphorus. This is my a very good summary summarizing the reactants required for the preparation of oxygen, the uses, and also the physical properties. And kindly follow my channel, click the notification bell, you get notified once I upload a new video. Thank you.